So today we're going to be going over a shorter lesson because it's going over one concept, which is aerodynamics. And I know you guys might hear aerodynamics and kind of feel intimidated, but it's a lot simpler than you think. So let's go ahead and get started. So aerodynamics is how air flows around things. Engineers use it to design cars, planes, rockets, even sports equipment, so they can move more smoothly and efficiently. So let's dive a little bit into physics, for example. I don't know if you guys can do this right now, but if you take the palm of your hand and you kind of just swing it through the air, you can feel air particles colliding with your hand, right? Not on the back of your hand, but with the palm, assuming you're swinging it that way. Um, that can slow you down when we're talking about bigger mechanics, right? Cars, there's a reason that they aren't just squares with wheels, right? If that were the case, we'd have all these air particles colliding with the car head on, and it would ultimately be slowing it down the way an umbrella might pop up if it's windy and raining, right? So that's why cars are a little bit more rounded at their tip. So instead of having so many collisions with the air, instead it kind of just glides through the air. Can anyone tell me some examples they notice about like the shape of a car or the shape of like their parents' car? Sarah, did you have an example? I'm not sure if I can hear you, but hopefully, hopefully you guys thought that one over. But yeah, that's what the overall idea of aerodynamics is. So let's go over the forces acting on flight specifically. Airplanes. So flying objects are affected by four forces. Lift, which is those air particles kind of pushing up on the plane. That's why the wings of a plane are angled the way that they are. And then there's also gravity, or the plane's own weight, naturally kind of pulling it down. There's thrust, which is the engine's working, pushing out air so that it can go forward. And then there's drag that we initially talked about, which is even though it has a more rounded tip, it's those air particles, colliding with the front of it and slowing it down a little bit. Basically, the goal for designing something like an airplane is to make it to where it will have greater lift than it will be in relation to its weight. So it's easier to lift up than it is to fall down by its own weight, or also greater thrust than it is to slow down by drag. So this is kind of what we just went over. Lift happens when air moves faster over the top of the wing than underneath. I know that kind of sounds like weird wording, but it's more so when, oh, how can I explain this? It's like particles are gliding over the top, but they're colliding with the bottom of the wing, which is slowing down its fall, aka like lifting it up. Hopefully that makes more sense. And then, we already went over gravity pulling everything back to the ground. Thrust and drag. Thrust moves an object forward, engines on a plane. Um, or for example, if you have a paper airplane and you push it, that would be its thrust. And then drag is the air resistance, air pushing back against that movement. So let's look at a real world example. Engineers study aerodynamics for cars, bicycles, rockets, even sports balls. I think I already mentioned that. And reducing drag helps them go faster and more smoothly. this is why we are going over this. This is an engineering applications class, and we want to know how to go around natural issues like this. Not issues per se, but just natural things that make our decisions in, inventions differently. So, for example, sport ball. A football is shaped differently, right? It's like an oval and it has like a pointy end, similar to the way that a rocket is shaped. So it can glide through the air quicker, and it's not going to have as much drag as a soccer ball has, for example. So I just want you guys to kind of think about that real world example. Okay, we're gonna do a quick activity. I'm gonna give you guys about 8 to 10 minutes, and I want you guys to go in your house and get two pa pieces of paper, like scissors, anything you need. I want you guys to make two different airplanes, paper airplanes, of course, and test them out. They can be different in their wing shape. Maybe you added like paper clips to some, so they can be different in their weight. I want you guys to test them out and then score them on different factors. Maybe one of them is quicker than the other, one of them spends more time in the air, another one is heavier. And be ready to come back and basically talk about what which one was better and why you think it worked better. So I'll leave this up here and I'll give you guys about 8 to 10 minutes. Also, let me know if you guys have any questions. But my tips would be changing the wing size, like folding one more on the second one you have. Good luck, you guys. Assignment nonetheless. The second part to this was to change something about your plane and see if it would perform worse or better. So, can you guys type in the chat if you think adding more weight to it would make it faster or if you think it would slow it down or just like overall what you believe adding more weight to a paper airplane would do. I'm gonna give you guys like a minute to type in the chat. That might have been a harder question. Um, so I'm just gonna go ahead and say that it was because adding more weight to it would likely um slow it down. That makes sense. Or also just generally bring it lower to the ground so it wouldn't reach a higher peak. Um, yeah, that might have been a harder question. Sorry about that, guys. This is the last thing I want you guys to do. I just want you guys to kind of do a recap of this. You guys can answer this in the chat, and I'll wait on those responses as well. Perfect. Okay, so I got a response, and because we're just about to end up and wrap up here, I'm going to give you guys the answer. Hopefully, it's more of a recap for you guys. So, the four forces of flight would include thrust, drag, lift, and gravity, or like its own weight. Now, drag slows down a plane, or, you know, I mean, you can try to have as much thrust as you can to make it to where there's minimal drag that can get in the way, but that's what drag does. And then thrust is what pushes it the other way. When you think of engines and how they're fans, they're basically pushing air out of the back, like they're pushing air back so that they can be pushed forward, if that makes sense. Um, if you were to be falling, hopefully you're not falling, but if you guys were to be falling mid-air and you had like I don't know, maybe you had like a heavy ball like just in your hand. And if you pushed it to the left, you would go to the right because momentum is conserved. So your center of mass with the ball would stay at its same place. If the ball is going one way, you would be going the other. That's more physics. I'm not going to get too much into that. But yeah, you would be going the other way. So that's what engines kind of do. They're pushing out air and, kind of clinging onto it so that it can be pushed out and they in turn can go forward. Like I said, this was a pretty short lesson, but I think it's one that gets a lot of people interested in engineering, especially aerodynamics. And it is also the last lesson. We have completed the 6-week engineering science course. So great job exploring and experimenting over the past 6 weeks. Keep building, testing, asking questions. I really do hope you guys enjoyed this course, and you guys will be receiving certifications of completion. Um, hopefully you guys can keep in touch. I know Adtechnical, we want to do a lot of other things, hopefully provide more education. Um, but yeah, that is the end of the mathematical and engineering applications course.